Hey folks, happy Friday. We're on page 188, 3.3, problem 1. (188) Oscar. Chris B, 188, please. I had a pen. Okay, quiet please. If you can hear me, snap once. If you hear me, snap twice. Thank you. Literal equations. Brody, probably time to put down your screen. If you're still on that survey, you can finish later, okay? Literal equations. Anna, could you read for us, please?
Literal equations are equations in which the variables represent specific measurements. You can most often see literal equations when you study formulas that these literal equations can be manipulated in order to allow you to solve for one specific variable.
A common literal equation is a formula for converting between Fahrenheit and Celsius. What's Fahrenheit and Celsius? Degrees. When do you usually have to convert stuff like that? Different countries. Okay, going to a different country. Maybe in science class, Andy. Okay, so Celsius and Fahrenheit. Most scientists use Celsius. Other countries use Celsius. Maybe you have a recipe or you bought a cake mix or something in one country, and maybe you need to convert because you got a thermometer in a different place. All right, so Celsius and Fahrenheit. The normal body temperature for a human is 98.6. Put a box around that, please. What scale are we using there? What type of temperature scale? Fahrenheit, because it has big F. If I'm going to put that into this formula, it's going to substitute into the formula where the F is. They're asking us to find a temperature in Celsius. C equals 5/9 parentheses. Instead of F, in order to convert, I'm going to put in the Fahrenheit degrees that I know, 98.6. According to my formula, I'm going to subtract 32 from that number. Go ahead, right now at your tables, find a value, please. There are calculators back behind Christian, if you didn't pick one up yet and would like a calculator. Subtract first, times and divide second. Okay, I can hear people at tables kind of arguing about what step. Does it matter whether you times or divide first? No, actually it doesn't. It does matter that you do this subtract first. Do the subtract. Do the inside parentheses first. And then you can times by 5, divide by 9. Times because the 5 is on top. Divide because the 9 is on bottom. Times by 5, divide by 9. I've got 37 degrees C. Are you in agreement? Go ahead and do number 2, please. Number 2, Antarctica. The 5/9 is the same each time. What's the temperature we're substituting in now? The -32 is always part of the formula. Remember too that in negative in your calculator, the button that does negative is down low and has little parentheses around it. It's different than a subtract. I'm walking around. Let's see if we get it plugged in here and get an answer. Coming up with. What are you doing? Do the subtract first. And good. Now from there, 9 plus 9 divided by 9. Ding, 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 here's magic. Ding, ding, Brian has it. Divided by 9. Good job.
Wait, we did 3 too.
No. Yeah, we did something twice. When you do it like this, you put that in parentheses also. It in a different order. Good. Christian has it. All right. Good. May I have your attention up this way? Martine, what do you get? -88 degrees C. Do we agree with Martine? Okay. Number 3. Cake box. You bake a cake at 177 degrees C. Uh-oh. I'm from the U.S. and I always do things in Fahrenheit. I don't know what to do with this. I need to convert. Okay? But what kind of temperature is this? Is that the same as what we've been working with? No. Why not, Andy? Pay attention.
What? Yeah, because there's different, like Celsius and Fahrenheit are different.
Celsius and Fahrenheit are different. Okay, now, as I go to use my formula, where am I going to put that 177?
On the other side of the equal sign.
177 goes where the C is in our formula, all the way over on the other side of the equal sign. I've been plugging things in for F because I had Fahrenheit values. Now I got to plug it in over here on the other side. So this is what it's going to look like. The 5/9 stays. This time I don't know an F. Now I've got to go -32. Oh, that's going to be tricky. That's going to be tricky because what they're asking me to do is get Fahrenheit all by itself. But it's buried deep inside of a parenthesis. The first thing I need to do if I want to get that F out of a parenthesis is if there's a number in front, I've got to get rid of it. we've dealt a tiny bit with fractions like this. A trick. We're going to flip that fraction and times. What do I mean by flip the fraction? Reciprocal. I'm going to go, let's times this by 9 over 5. I'm going to sneak it on in there. I'll keep my equals bigger. But I got to do the same thing on the other side. So this 5 over 9, I'm timesing by its reciprocal because I want to get f out of the middle of that parenthesis. Notice right here, 5 and 5 can cross cancel. 9 and 9 can cross cancel. How do I do the math right here for 9 over 5 times 177?
Did you put a 1 under the 177?
That will help. Now it's a little easier to look at. So I've got to multiply. What two things am I going to multiply first? 9 and 177, yes? And then on bottom, I'm going to multiply 5 and 1. All right, so here we go. 9 times 177. 1593 over 5 times 1. Now I have nothing in front of the parenthesis. I can get rid of that parenthesis. So at this step, I multiplied by reciprocal. I don't like the looks of this, though. I'm going to simplify. What can I do to simplify this yucky-looking fraction? Divide. The 500 means divide that. So 1593 divided by 5. It's going to have a decimal, but that's okay. 318.6 equals f minus 32. Real life is very rarely whole numbers. We have fractions, we have decimals. Okay, now I want to get f by itself. What do I have to do as a last step? Oh, and that's looking like what I would cook a cake at. F equals 350. I could have just told you that. Baking a cake, set it at 350. Check it. If it needs more time, give it more time. But here we go. This is math. So 350.6 degrees Fahrenheit. Question number 4. Andy, could you read number 4 for us?
Is there a more efficient way to determine degrees Fahrenheit than the method used in problem 3?
Problem 3 was a lot of steps. What do you think is a more efficient way?
Less steps.
Less steps? How can we make this have less steps? Excuse me?
Look at a thermometer.
Oh, do you take 2 thermometers and look at them side by side. Look at a thermometer. That's what I would do, but we are in go on the internet. There's something to convert everything on the internet, yes? But we are in math class, so if we were in a cave and didn't have an internet, but we had a pencil and a calculator, okay, here's what else we could do. In order to get less steps, we could rearrange our equation. Get f by itself. We can rearrange our equation so that we're already set up to solve for f, and that would give us less steps. Okay? Convert the given formula to degrees Fahrenheit. Show our work. We're going to start with C equals. We can rearrange this pretty much the same way that we solved for f the last time. What was the first thing we did down in question number 3. Take a look at question 3. What was the first? Reciprocal. This fraction in front we flipped and we multiplied both sides. The reciprocal of 5 over 9 is 9 over 5. Last time I had a C value. This time I'm just going to put the letter C. Timesing by right here by the reciprocal, 9 over 5. Remember that crossed canceled everything. So f minus 32 is what's left. Show and explain times by reciprocal. We had a fraction in front of our parentheses. We got rid of it by multiplying both sides by 9 over 5. Okay, right here, what was the step? If we want to get f by itself, what did we do? We did this already, but we didn't know a value, or we knew a value for c. What do I need to do next to get f by itself? Do you agree, Brody? Because if I go plus a 32 here and plus a 32 there, it looks so ugly over there. I'll show you what to do. Thank you. If I add those two, that's what I want. That's going to give me f by itself. This is how you're going to write this side. Those two don't actually add because this has a c and that doesn't. So we write 9 over 5c as an expression added to 32. So here's that formula rearranged with f by itself. Number 6, hottest temperature ever recorded on Earth occurred in Africa in 1992. It was 57.8 degrees C. Do you guys have any idea what this room temperature would be in Celsius?
42, no 32.
32. Somewhere in the 20s to 30s, yes?
Yeah.
Okay. So 57.8 is pretty high in Celsius. Okay. But let's go ahead. We're going to use the formula we just created and figure out how high is it. This 57.8 again is a Celsius. So where do I put it in my formula? Where the C is, I'm going to substitute. Myra, are you awake? Yeah. Okay, so here we go. 9 over 5. Replace the C with 57.8. Plus 32 is part of the formula. F is what we're looking for. Take your calculators. Do that math, please. You need to do this multiply first. PEMDAS, multiply, then add. Leave that 32 alone until you figure out how to do this on your calculator. On. Oh, that's hot. That's hot.
Is it 64.1?
No, that's not what I got. It's not that hot.
Skill. 130.
Learn your own.
Oh my god.
Oh, you times by 5 over 9, you got times by 9 over 5. What you have written down? See 9 over 5?
I did 8 over 5.
No, you did 57.8.
Oh.
Okay, so you just did it by the wrong fraction.
That's really cool.
Good. Good. Go ahead, write that down.
That was nothing that.
Around here, if we said it's going to be 85 degrees, we'd say it's hot, right? Right in here, if we said it was going to be 100 degrees, we'd be, oh, cancel school. Okay? That is 136 degrees.
How hot does that have to be so you
I don't know. It doesn't happen around here. That is roasting. Okay?
roasting chicken?
We'd be melted. Okay, you guys go ahead and do number 7, please. Be careful with that negative. I'm going to walk around and help.